When you think of Jupiter, you probably imagine those iconic orange and reddish bands and the colossal Great Red Spot staring back at you. But did you know that these bands aren't static? They change in size, color, and location every 4 to 5 years. Today let's dive into why Jupiter keeps changing its stripes and the magnetic secret behind it. First off, these bands are made up of ammonia and water clouds floating in a hydrogen and helium atmosphere. Each band corresponds to strong winds blowing east or west, and they extend over 1,000 miles deep into Jupiter's atmosphere. Now, scientists have linked these bands to infrared variations within the planet, but there's more to the story. Recent research using data from NASA's Juno spacecraft has revealed a fascinating connection between these band variations and Jupiter's magnetic field. It's all about magnetic waves called torsional oscillations. Torsional oscillations means the twisting or wobbling of an object around an axis. Torsional oscillations in Jupiter's dynamo region affect the planet's weather. These oscillations in Jupiter's magnetic field correspond to the periods we see in the planet's infrared radiation. In simpler terms, when the magnetic field of Jupiter wiggles, it affects the atmosphere and those famous stripes. Now, while we've established this correlation, the exact mechanism remains a bit of a mystery. Scientists are still figuring out how these torsional oscillations cause the observed infrared variations and subsequent band changes. It just goes to show how complex and dynamic Jupiter is. To help you visualize this, let's compare it to Earth. On Earth we have atmospheric cells where warm air rises at the equator, cools, and then sinks at higher latitudes. This creates alternating belts of atmospheric circulation. Jupiter has similar atmospheric cells, but its weather is way more extreme, and its atmosphere is quite different. On Jupiter, the top layer of clouds is made of ammonia, creating those bright white zones. Below this, there's a second layer of mixed clouds, giving us those darker belts. And because Jupiter spins faster than Earth, there are even more of these cells, making the stripes more pronounced. Other gas giants like Saturn, Uranus, and Neptune also have banded atmospheres but look different due to temperature and atmospheric composition. For example, Saturn's bands are less distinct due to hazes, while Uranus and Neptune appear blue because of methane clouds absorbing red light. So next time you look at Jupiter, remember that those mesmerizing stripes are not just a pretty sight. They're a dynamic system influenced by the planet's magnetic field and complex atmospheric processes. And thanks to the Juno mission, we're getting closer to unraveling these cosmic mysteries. If you enjoyed this deep dive into Jupiter's stripes, don't forget to like, subscribe, and hit that bell icon for more mind-blowing science content. Until next time, stay tuned and watch other videos at JPJE Discovery.